Hi, today we are going to discuss about Fibonacci series. There we are going to solve the Fibonacci series normally, and that will not work because we are going to get time limit exceeded, and after that we are going to use dynamic programming to solve this problem. First of all, we need to know what is Fibonacci number. So Fibonacci number, it is nothing but the sum of previous two numbers. That is what Fibonacci number means. Imagine it will start from 0, it will go, and the and next number is 1. So now the next number in the Fibonacci series will be 0 plus 1, that is 1, and the next number will be 1 plus 1, this 1 plus 1, that is 2. The next Fibonacci series number is 1 plus 2, that is 3, and next Fibonacci number is 2 plus 3, that is 5. So our job is so much simple. I will be having index. It will be starting from 0, 1, 2, 3, 4, 5. So if I ask the user to give me the 0th Fibonacci number, then I should get 0. If I ask user to give me the first Fibonacci number, then I should get 1. If I ask 5th Fibonacci number, I should get 5. So this is our objective, and to solve that we are going to use recursion, and there I am going to explain. First of all, let us write the code. After that we are going to discuss about how we need to write the recursive tree. So first of all, as I said, if let me increase the size. Okay, if I will be having a function. Imagine I have a function that returns int, because the number we need to return, right? Integer value we need to return. And let me call the function name as, let me give the function as f, or you can give fibo, like anything you can give. I will just take fibo. After that I will be passing an integer, that is the position I'm going to pass, and I'm going to return the number, the Fibonacci number at that position. So let me take it as n. So here, if n will be equal to 0, that means if I'm asking for the first that is 0th index Fibonacci number, at that time you need to return 0 itself. So these are our base condition. So in recursion, base conditions are so much important. It will not work if there is no base condition. The recursion will not work, because when you traverse through the recursive tree, you will get to know how the recursion will make use of the base cases every single time. So now let us move to our code. That is, again, if n is equal to 1, then you return me 1. That means you return me 1. Okay, here if you are asking for the for this first Fibonacci number, I should return 1 itself. That is what it means. So after that I am going to return Fibo of n minus 1 plus Fibo of n minus 2. That means if this will not run, if this is not returned, or if it is this, if this don't return, then what you return me is Fibo of n minus 1. That means, example, if I am asking for the 5th Fibonacci number, since n is not equal to n is 5, at that case n will be 5, so it is not equal to 0, so it will be not equal to 1. So you return me Fibo of n minus 1. That means Fibo of 4 plus Fibo of 3. So it is so much logical, right? If you are going to add, you should get 5, right? Sorry, This is our the Fibonacci number. So you here I'm going to pass in the Fibo. I'm passing n minus 1, that is 4. That means I'm passing the index, that is the Fibonacci number, that position I'm passing, plus Fibo of n minus 2, that is 3. I'm passing this position. What you return is, you return 2 plus 3 for me to this 5. Again, if you don't get 2, then again go back and find other two, and at some case other two numbers. So you go on doing like this. At some case you'll reach the base cases, and at that time you can return me the base cases. And again, while coming back through the recursive tree, you are going to add up those answers, and you are going to give me the solution. So it will be so much easy if I draw the recursive tree. So we have this function here. Imagine I am going to find the recursion. My function is, I am calling for, imagine for again 5. I will take the 5 as our fifth position Fibonacci number I need. So 5, I am going to write this 5 here like this. Then what it does, see, it will go here, it will see whether n is equal to 0. No, don't do anything. If n is equal to 1, no, don't do anything. If it is not 1 or 0, then you return me Fibo of n minus 1 plus Fibo of n minus 2. Here I am changing the name of the function, that is f, because it will be easier for me to draw. So what I do is, I will make I will call for two functions here, f of n minus 1, that is 4, then again plus Fibo f of n minus 2, that is 3. So one thing to remember, actually the recursion will not happen like this. What happens is, it will call for Fibo of 4, right? It will call for Fibo of 4, and it will not reach to this Fibo of 3 suddenly. It will actually go again here, then it will call for Fibo of 3, n minus, again n minus 1, that is 3. This is how it works. So while returning while returning, it is going to do this operation. So for our understanding, what we are going to make is, we are just doing concurrently, we are doing this recursion. Just for our understanding, we are going to do both at once. Okay, then f of 4, and what f of 4 calls for, since it is not 0 or it is not 1, it should call for f of 3 plus f of 2, right? F of, sorry, it will, okay, I will draw here. Okay, it will call for f of 2. Again, it will come here, and it should call f of 1, sorry, 2, and f of 1, right? F of 1 it should call. Again, 2 is not equal to 0 or 2 is not equal to 1. What it does is, it will again call for f of 1 plus f of 0. So this is going to happen. After this, after that, you are passing 1 from here. If you pass 1, this condition if statements will be satisfied. That is why it will return 0. So it if this will be not satisfied, actually this will be satisfied. This if statement, that is n is equal to 1, will be satisfied, and so it will return 1. And for this function, it is going to return, so it will return 1, right? Okay, after that, it will go back, and while return and it will execute this function. So here this function is f of 0. So what it should return? It should return me 0. So it will return 0. After that, we need to add them. We need to add, that is 1 plus 0 will be 1, right? This will be giving 1. This will be giving me 0, and 0 plus 1 will be 1, and we are going to get 1 at this place. So after completing this one, it will go to this function, as I said. while returning it will execute this function. So it should execute this one. So I'm going to draw again f of 1, it will be called, f of 0 will be called, again f of 1 will be returning me 1, and f of 0 will be returning me 0. Again we should add this 0, 1 and 0. Again what we get at this position will be 2. I will directly write this one here. It is 2, right? uh, Sorry, 1 plus 0, that is 1. Sorry, we need to it will return 1. So I will write this in red color. So here also we got 1. Okay, see here it will be returning 1, right? Actually this will be not executed. I'm so much sorry for this. I have left this function, that is f of 1. Even that should work, right? Okay, actually when it will be returned, 1 will be returned to f of 2, you know what will happen? This function will be executed. This function will be executed, as I said, while returning this function has to be executed. So this function f of 1 will return directly 1. So 1 I am going to return to this function. So 1 plus 1 will be 2, right? This will be 1, and 1 plus 1, let me make it as red, and 1 plus 1 will add up and give me 2 here. So similarly at f of, and now while returning time I have to execute this function, right? So here that function is f of 2. Again let me draw recursive tree. F of 1 plus f of 0. So again f of 1 will return me 1, f of 0 will become 0, while what it returns is me is that 1 plus 0, that is 1. I already returned this one here. So after that it will go here. Then again it should execute f of 3, right? While returning time I should execute this f of 3. Again if I do f of 3, what I am going to do, what I am simply doing is I'm just doing this thing again. This whole thing I have to do it again at this position. After doing that, what I am going to get, I am going to get 2. So normally if you write recursion like this, what happens is we need to again solve this. Computer is going to solve this recursion like this, calling many number of times, and it will return 2. Let me draw for my convenience. I will draw 2 here directly. So after that so actually f of 4 will get the value, right? 2 plus 1, it will be getting 3. So after that this function will be called again like this. Every step will be computed. Again we are going to get 2 here. 3 plus 2 will be 5. So the 5th position Fibonacci number will be 5. So this is correct. This is how it works. So this function should work for me, but it will give me time limit exceeded. Let us see. First I am going to submit this problem. I have n, that is the nth Fibonacci number I need to return. As I did earlier, what I do is I will call for the function. I will return I will create a new function called Fibo. Let me call it as Fibo. Then let me take the I will send n as a parameter. Then again here long int, right? And again Fibo. After that I am going to take the same n value as long int. I'm just copying this thing and pasting here. So after that, if n is equal to 0, or like if I'm simply changing some code, it will be easier to read to you. What you do is you just return n. That means if it is equal to 0 or if it is equal to 1, you just return n. That is what we did, right? Or else what you do is return me Fibo of n minus 1 plus fibo of n minus 2. That is what you need to return. Again, the problem is given here, and we need to here they have given me, since the answer will be huge, I have to return the modulo of this. While simply what you are going to put is, while returning the answer, you are going to take a modulo of n. Here n will be this number. So let me write n value, let me define the n value here as let it be int let me call it as a n, let it be 1. Again, I will copy and paste this value. So this is what the value is. So it should work to, okay. So I am going to get the this will be returned to this function, and we should get the answer now. Let us see. So if okay, I am getting the answer. That is the second will be second Fibonacci number will be 1, right? Yeah, as you can see here, a second Fibonacci number is 1. So that is not our problem. The problem is, if I submit, I am going to get TLE, that means time limit exceeded. So I am getting time limit exceeded. That means I need to use dynamic programming here. Dynamic programming is so much simple. If you can do this much, you can easily you don't need to think about it. It is only adding 3 lines. That is how dynamic programming works. So what you are going to do is, I will explain you here itself. For what I did here is, for f of 3 I return 2 directly. Why I return 2 directly? Because it will be, I know f of 3 will be giving from looking at this recursion tree, I got that f of 3 will be having 2 as a result. So instead of drawing recursive tree, I have just written 2 here. So same thing I am going to do for computer also. It don't need to return so many times. Like, see, it will call for 4, it will call for 3, it will call for 2, it will call for 1 and 0. Let us forget about this. It is base cases. And when f of 2 will get the value 1, right? F of 2 will get the value 1. So I'm going to store this in an array, right, or vector. I'm going to store this value. Why? Okay, after that f of 1 will be executed, and base case will be returned, and after f of 3 will get 2. Again f of 2 is called. Don't need to call, now I don't need to call this function at all. I will go to vector, and I already have a value for this, so I'm going to return directly it as 1. So after that, what I am going to do is for f of 4, again I will get the answer like that. Then f of 3 will be called, right? Directly I am going to give f of 3 value for this. So this is how it works. Directly I am going to store this one. For that, I need to create a vector, right? Let me create a vector. Let me call it as a let me take int vector, because first of all we need to know how much is the n value, how much n can be reaching. We can how much n can be reached, and that n value here is, they have given 1000, right? Let me take vector size as 1000, that is 1005. Let me take it as 1005. Actually it is just you can take simply give extra 5 or 10 size here. So after that, I am going to fill those spaces with the -1 value. If I am going to find like, again I will explain you this. I have created a vector. Imagine I have a vector. I am going to fill initially with -1, -1 and -1. If I get any value like f of 2, I will get for f of 2 I will get the result as 1, right? So for f of 2, that is the index 1 at here, I am going to substitute with the 1. So if it is not -1, you return me this one. If it is minus 1, then you replace this one. So I think it will be so much logical. See, if it is minus 1, then I have not got the answer for this node, for this at this position. So I'm going to fill this position. If it is not minus 1, then I will be already filled this one, right? I should return simply this one, this element. That is how it works. So let me write the code for this. I have taken some extra memory. You can do, you can take actually extra 10 memory, there will be no problem. Even if you take 1000, there will be no problem. Again, I have created the DP. Then I will I will say what I do is, it is a global, right? So I can access anywhere. So if DP of I, that is sorry n, if it is not equal to minus 1, you just return me this DP of n. So I have already stored that value. You don't need to do anything. You just return me that one, that value. And while after that, if we then I'm going to fill dp of n as this value. Means I'm just filling this value at this position for the future use. That is why I'm going to use dp here. So only 3 lines I have added. One is this one is if else statement, and then while returning I'll just add this thing here. So if I run this one, it should work. So I will compile. Let me see whether I get error or not. Okay, there is no error. Let me submit. So if I submit, I am going to pass all the test cases. Yeah, that is how it works, right? So this is how DP works, and that is so much easy. If you, why I am explaining with this Fibonacci, which might you already know, right, how this Fibonacci work, but still why I explained is how to apply DP is so much important here. So thank you for in the coming video I'm going to cover much problem on DP. So you can subscribe to my channel and like this video if you feel it is somewhat informative, and thank you.